Welcome back, and in this video we're going to look at some titration calculations that you might find in a typical paper 1 or paper 3 exam question. So you're going to need your notes. We're on page 23. You're also going to need a calculator. So the first thing we have to do is write out a balanced equation, because this is going to give us the molar ratio between our reactants and our products. So in this case I've got sulfuric acid reacting with sodium hydroxide. So that's going to be H2SO4 sulfuric acid and sodium hydroxide NaOH reacting to form sodium sulfate Na2SO4 and water. It's typical acid-base mixed salt and water. We need to balance it. Well, we need a 2 in front of the sodium hydroxide, and we're going to make 2 waters. So that's nice and balanced now. The first step we do, and it's always the same, the first step we work out the number of moles. So the number of moles that we can work out in this case is the sulfuric acid, because I've been given both the volume and the concentration of the sulfuric acid. So the number of moles of sulfuric acid is equal to my volume, 12.5, divided by 1,000 times my concentration, which is 0.5. If you can't remember that equation, you are going to need to go back and look at the previous videos and relearn it. Do remember you're not given any formulas in chemistry. So I work this one out and I get 6.25 times 10 to the minus 3 moles. So that's the number of moles of sulfuric acid. The next step is the molar ratio. So that's the ratio between what I know, which is the sulfuric acid, and what I'm being asked to work out, which is the sodium hydroxide. And from my balanced equation, it's a 1 to 2 molar ratio. In other words, I need double the number of moles of sodium hydroxide to neutralize all of the sulfuric acid. So the number of moles, you can think of this as step 3 if you like, number of moles of sodium hydroxide is equal to 2 times this, so that comes to 1.25 times 10 to the minus 2 moles. Now I need to work out the concentration, because that's what I've been asked to work out. So that's my last step. So concentration is my number of moles, 1.25 times 10 to the minus 2 times by 1,000 divided by the volume, which is 50 in this case, and I get a concentration of 0.25 moles per dm cubed. So our second example is looking at calcium hydroxide and hydrochloric acid. So again, I have my formulas. So I have calcium hydroxide reacting with hydrochloric acid to make calcium chloride and again water. Again, I need to balance it. Well, I'm going to need 2 hydrochloric acids for every 1 calcium hydroxide, and I'm going to make 2 waters. So again, I need to work out the number of moles. In this case, I've been given both the volume and the concentration of the hydrochloric acid. So that's what I'm going to work out the number of moles of. So I've got 24.0 divided by 1,000 times the concentration, which is just 1. So that is 2.4 times 10 to the minus 2 moles. So that's the moles of my hydrochloric acid. Again, I need that molar ratio. So I've got what I know, in this case the HCl, versus what I want to find out, which is the calcium hydroxide. And this is a 2 to 1 molar ratio, 2 to 1. Another way of writing that is 1 to a half. So I need half this number of moles of the hydroxide. So I have 2.4 times 10 to the minus 2. Therefore, the number of moles of calcium hydroxide equals 1.2 times 10 to the minus 2 moles. I've been asked to work out again the concentration. Well, the concentration is equal to my number of moles, 1.2 times 10 to the minus 2, times by 1,000, divided by my volume of calcium hydroxide, and in this case it is 25. So 25, and I get a concentration of 0.48 moles dm to the minus 3. So question 3, this time I've got sodium carbonate reacting with sulfuric acid. So again, the first thing I'm going to do is write out my balanced equation. And I have sodium carbonate Na2CO3, and this is reacting with my sulfuric acid H2SO4. It's carbonate acid reaction, so it's going to make salts Na2SO4, sodium sulfate, and CO2, carbon dioxide, and water. And that's a nice balanced equation for me. So I've got my solution of sodium carbonate, and it's requiring 17.5 centimeters cubed of a 0.05 concentration solution. So I'm going to work out the number of moles of my sulfuric acid. So the number of moles of my sulfuric acid, H2SO4, is equal to 17.5, my volume, divided by 1,000 times my concentration, and that gives me a value of 8.75 times 10 to the minus 4 moles. This time the molar ratio is nice and easy because the molar ratio between the sodium carbonate and the sulfuric acid is just a 1 to 1. So if I've got this many moles of sulfuric acid, I'm going to need the same number of moles of sodium carbonate. So working out the concentration in moles per decimeter cubed, it's going to be moles 8.75 times 10 to the minus 4 times by 1,000 divided by the volume, which in this case is 25, and that gives me a value of 0.035 moles dm to the minus 3. I've been asked for it in both moles per decimeter cubed and grams per decimeter cubed. So to convert from moles per decimeter cubed to grams, I'm simply going to times through by the RMM, which is 106, and that gets me 3.71 grams per decimeter cubed. What I'm doing is converting from moles to mass, so I times by the RMM. And we're on the top of the next page, and it's again a very similar calculation, but this time we just need to be careful of the dilution effect. So again, we've got sodium carbonate. This is anhydrous, so it's got no waters of crystallization, and it's reacting with hydrochloric acid. So again, I need to do my equation, HCl plus Na2CO3. And again, it's an acid carbonate reaction, so it's going to go to sodium, chloride, and water, and carbon dioxide. Again, I need to balance it up, so I've got 2 in front of my sodium chloride and a 2 in front of my hydrochloric acid. Now what I need to do is to work out the number of moles. So this time I need to start here with this 2.5 grams of my sodium carbonate, and I know the volume it's made up in, and I know how much I took out to neutralize my hydrochloric acid. So I've got 2.5 grams of my sodium carbonate. So the moles of my sodium carbonate, Na2CO3, is my mass, 2.5, divided by the RMM, which is 106. and that gives me 0.02358 moles. But we've got to remember this is the number of moles in 500 because that's what we dissolved it up into. We want to work out the number of moles in 25. So the moles of my sodium carbonate in 25 centimeters cubed is going to be this number, 0.02358, divided by 500 and then times by 25 to scale it up. So I get 1.179 times 10 to the minus 3 moles of sodium carbonate in my 25 centimeter cubed sample. So I know from my equation it's a 1 to 2 molar ratio, so I need twice the amount of HCl to neutralize all of this sodium carbonate. So the moles of HCl is equal to twice this amount, so I have 2.3584 times 10 to the minus 3. And I've been asked to work out the centimeters cubed. So I've been asked to work out the volume. So the volume is equal to the number of moles, 2.3584 times 10 to the minus 3 times by 1,000 and divided by the concentration, which in this case is 0.1. And that gets me 23.58 centimeters cubed. So to 3 sig figs that would be 23.6 centimeters cubed, which comes out as a reasonably accurate value. So the last question is looking at hydrated sodium carbonate. Although it says extension, this is a question likely to be found at the latter stages of a paper 3. So it's one that you do need to be able to solve if you're looking to get an A or a B grade in the final exams. So this time we've got 8.58 grams of soda crystals. Now these are hydrated sodium carbonate. So we can't use the same method that we used in the previous example, just dividing through by the RMM to find the moles, because we don't know the RMM. The formula of the hydrated sodium carbonate is Na2CO3 dot X H2O, and I don't know how many waters of crystallization, how much hydration there is in my crystals. So that's why I can't just divide through by the RMM. However, only the sodium carbonate part of the crystals will actually react with the hydrochloric acid. So I can find out the number of moles of that bit in my washing soda crystals, and hence I can find out X. So we're going to start this in exactly the same way that we would usually do. We start with an equation. So it's the same equation we've seen before. Acid plus carbonate gives salt, water, and carbon dioxide. So we know from reading the question the volume and the concentration of the hydrochloric acid needed to neutralize just this sodium carbonate. So I'm going to work out the number of moles of the hydrochloric acid, and that's going to be my volume, 30, divided by 1,000 times my concentration, which is 0.2, so I get 6.0 times 10 to the minus 3. The molar ratio between the HCl and the Na2CO3 is a 2 to 1, or another way of saying that is the ratio between the HCl and the Na2CO3 is 1 to a half. So I'm going to need half this amount of Na2CO3 sodium carbonate. So the moles of sodium carbonate is equal to 3.0 times 10 to the minus 3, in other words, half that amount. Now, I need to be a little bit careful, and this is usually where students go wrong. This is in the 25 centimetre cubed, so it's always useful to put down the volumes. That came out of a solution of volume 250. So actually in the 250, I have 10 times that amount. So I actually have 3.0 times 10 to the minus 2 in my 250 centimetres cubed. So that's number of moles of pure Na2CO3. So as the first part of the question answered, I now know the number of moles present in the 250. To find the mass of my sodium carbonate in that 250, I'm just going to take that 3.0 times 10 to the minus 2, and I'm going to times it by the RMM, which is 106, and that gives me 3.18 grams, and that's of the Na2CO3. But we know the mass of the Na2CO3.XH2O is 8.58 grams. So the difference between those two is going to be the mass of the water. So the mass of the water is equal to 8.58 minus 3.18, so that's 5.40 grams. This then takes us back to an empirical formula calculation, or a waters of crystallization calculation that we did in moles 1, because I have my sodium carbonate and I have my water. So I have my mass of this as 3.18, I have my mass here, 5.40, divided through by the RMM, which in this case is 106, so I get back to 3.0 times 10 to the minus 2, and 5.4 divided by 18 gives me 0.3. Divide through by the smallest, which in this case is this number, and I get a 1 to 10. So therefore the formula of my sodium carbonate is Na2CO3.10H2O. In other words, X is equal to 10. And that's the last part I was asked to do. So that finishes this video looking at moles 3. And together with moles 1 and moles 2, that builds up a picture of how to use moles to calculate solids, gases, and now solutions. You're going to practice a lot of these along with the practical techniques in class, and if you do maths for chemistry, you're going to be practicing them there as well. But you do need to get comfortable with using those equations in all sorts of different circumstances. So until the next time, take care, stay safe, bye-bye.